is our hypotheses. So in a set of hypotheses for a mean, we're going to use mu. So mu equals the claim, which mu naught is what we're going to call our claim here, which is 24 minutes. Remember that x bar is the sample mean, which is 32 minutes, and sx is the standard deviation, which is 5.5 minutes. So just to have those ready to go. But mu equals the claim number is what we're going to go with in our hypotheses. And HA is that mu is greater than 24. And why we're picking greater than is because the question asks the word more. So from there, we have our conditions, which are the same as they have been for one mean. So random sample, 10% condition, and 35. It is in fact bigger than 30 for our large counts. Our t-score. Why we're using a t-score here is because we do not know the population standard deviation. We only know the sample standard deviation, so we can only go with t. So t equals statistic, which would be x bar, minus parameter, which would be mu, not over standard error. So standard deviation over the square root of n. So if I plug all our numbers into that, we have 32 minus 24 over standard deviation is 5.5 over the square root of 35. That was our sample size. You can compute that in your calculator, or you can use the calculator function t-test, and then that's going to give you a t-score of 8.605 and a p-value of 2.356 times 10 to the negative 8th. Remember, if you see a p-value that is not starting with a decimal, keep reading in your calculator because you can guarantee you that it's a really, really small number. So keep in mind it's 10 to the negative 10th actually, even smaller. So that would be that would be 9 zeros. 2, 3, 5, 6. So your p-value is super small. We reject H naught since our very, very small p-value is smaller than what we typically set alpha at 0.05. We have evidence of Chagrin Falls students spending more than 24 minutes per day on Instagram. And there you have it.